Okay, so welcome to the Young Women for OR webinar about machine learning and operations management. I am Vanesa Guerrero. I will be moderating this webinar today. I'm one of the members of the event subcommittee of the Euro Wisdom Forum. And first of all, I would like to share with you some information about what wisdom is for those of you that are not, or that it's the first time that you attend to one of our activities. Well, the Euro Wisdom Forum is an instrument of Euro to provide support and empower the participation of all genders in operations research. And in particular, well, it has kind of three main aims, and the idea is to promote inclusivity by means of different actions. First one is advising or highlighting best practices to the executive on issues women in OR face. Also to promote networking and mentoring, and in particular for young women in operations research and for women in the early stages of their career. And also promote a conversation around how operations research can be utilized to help to create a diverse and inclusive future. You can find the Euro EDI policy on the Euro website. So the Young Women for OR initiative is part of this second aim or goal. And well, the idea is to highlight, to give visibility to some young women in operation research working both in academia or in industry. And the idea is to providing this support and networking and mentoring opportunities through the Euro channels. Each year, 12 young women are selected, and I would like to introduce you the 2023 cohort so that you can see their faces, their names, and also their countries. Today, we will have the opportunity of listening to three of them, who are these three nice women that we have here. First, Shany Azaria will present her work. Then Fatima Ezzahra will present her work as well. And finally, Kseniia Kurishchenko. They will introduce themselves and also their work. Today, we also have the pleasure of having Professor Coralia Cartis as a subject matter expert. Professor Cartis is a professor of numerical optimization in the Mathematical Institute in University of Oxford, and also a Turing Fellow of the Alan Turing Institute for Data Science. She has received many prizes and awards, such as the Leslie Fox Prize or the Informed Simulation Society Outstanding Paper, among others. She's also a Science Fellow and a Europe Fellow in 2023. And she was a plenary speaker in the 31st Euro conference, the one that was hybrid in Athens and online. Her research interests are in nonlinear optimization, algorithm analysis and implementation, and also applications of optimization and machine learning. So this is, I'm going to stop sharing my screen now. Each of the speakers will have 10 minutes for presenting their works. And after that, Professor Cartis will discuss about those presentations, and she may ask some questions to the speakers. And finally, we will open up the opportunity to the audience to also ask their questions. So please, Shany, if you want to start sharing your presentation.
Okay, can you hear me?
Yes, we can.
Okay. So hi, first of all, my name is Shany Azaria, as said. I'm a postdoc fellow here at University of Toronto, now at the Rotman School of Management. What I'm presenting here is a joint work with Noam Shamir, my PhD supervisor, that is a part of my dissertation. So unfortunately, I don't have to convince anybody about the motivation behind this research. It is common knowledge that court systems are congested systems and that this congestion causes extreme delays. However, when I was working with judges, I encountered a misconception Well, everybody agreed about the negative external consequences of this congestion and long waiting times. They seem to overlook the internal consequences, the internal negative consequences of these delays. So imagine a case waiting months and months between two trial hearings. The misconception was that it's dormant. So the question that we are asking, indeed, are these cases sleeping or are they alive? So is there inventory holding costs in services? So our hypothesis is that in extended load environment, meaning like the court system with perpetual backlog, in-process delay, again, not just long queues, but in-process delay increases the demand for servers' effort, the judge's effort, due to external changes in work content. So while it is already established in the literature that congestion in this type of environments causes long length of stay or long lead time, what we're looking at, what are the consequences of this long lead time? And we hypothesize that it causes changes in work content. Why? Again, because cases last years and years, over those years, things can happen, right? Life is dynamic, so conditions can change, medical condition in a malpractice lawsuit, lawyers can shift, can change, a turnover, and witnesses and experts sometimes lose their relevance. So over the years, the age of the case causes changes in work content. Those changes further increase the demand for the judge's effort because they basically create more work. If that is true, that means that we have what we call a congestion vortex. So if congestion increases the demand for effort, this further burdens the system. I'm not going into a lot of details in the literature review, just because we only have 10 minutes. I just want to frame where we're at. This is extended load environment, which means basically that there's very high workload over time. So it's not seasonality and it's not, there's no peaks. It's extended load over time. We're looking at the effect of length of stay. So not the effect of congestion on length of stay, but the effect of length of stay on changes in work content. And these changes are framed to be not induced by the server. So it's not a behavioral server behavior issue. It's external changes. So in a nutshell, the civil judicial process is divided into two parts. The first part, the pretrial phase, is where you assemble the case, you gather all the information and all the documents, and there is a point in time where the case is set to go into trial. That point in time basically declares that the content of the case is set. And from this point onwards, nothing is supposed to change. In fact, if I would only have one judge and one case just sitting to hear the trial, most cases will probably end in a couple of days. So all the waiting time is translated into lead time, and that basically lead time is considered as delay. Again, if we didn't have congestion, we would have finished it in 2 days rather than 2 or 3 years. So from this point onwards, we're going to focus on the trial phase. So the content is meant to be set, and delay and lead time is considered as delay. We have 2 data sources to examine our hypothesis. The first is a very detailed data set from the Israeli Court System Research Division, who created statistically validated effort estimations measured in hours to every judicial task in the case life cycle, over 165 case types in the system. And the second data set is a very detailed data set of all the civil cases in the system for almost a decade, with all their attributes and all the events that happened in the case, including all the hearings and all the decisions in motion. When we restrict the research period and focus only on cases who had a trial phase, we have almost 50,000 cases. A little descriptive statistic to get a sense of this environment. I just want to point out the average total lead time in our data set is almost 40 months, okay? The trial phase lead time, this is the average. You can see that the median is slightly lower. The trial phase lead time is over 14 months. Another variable of our interest is effort. So what is effort? How we measure effort in this setting? Effort is a multiplication of the number of decisions in motions in the trial phase with the individual time estimate of this specific task from the first data set. So what is a decision in motion? A motion is a request or a form of communication between the parties and the judge where they declare things that they ask, they have questions, they have requests, and what the judge needs to do is to take those and make a decision. Since we're looking at the trial phase, our trajectory is that requests and motions in this phase considered or are due to changes in the work content. And the decision that treating those motions are the excess effort that we're talking about. So we're trying to estimate effort using lead time, the trial phase lead time, but as you probably all know, we have a huge indigeneity issue. First of all, because of reverse causality, right? Because if longer cases require more effort, cases with more effort might also take longer. So to deal with this reverse causality, we employ the IV approach. We use two instrumental variables, which are exogenous shocks to lead time. One is a military conflict in 2014 of a few weeks. The other is a court workers' strike in 2016. To make sure that we have balanced group in terms of case mix, you can see here. You can see differences in cases outcome, which I'll relate to later, but we can already see differences in the lead time as well as in the effort, both in the total time of the case and in the trial phase. So to make sure that we have good IVs, the first thing that we do is we do a regression of the IVs on our lead time. And as you can see, we see not just a significant, but a big effect. So this is 11 months and 13 months. This is basically, we've talked about the IV being a few weeks, but the effect is very, very big. The reason for that is the Q re-entry. When you have a highly congested environment, every Q re-entry basically increases the lead time significantly. The second condition, the exclusion restriction, we're trying to rule out that the IV affects effort not through lead time. So we found a proxy for those unobserved factors, which is the number of pretrial sessions to capture any differences in complexity. And our tests have shown that if ever the cases included in the IV should be less complex. So we see our estimates as conservative in that sense. So the second stage is estimating the effect of the predicted lead time on the probability of having those changes, having those issues in motions. We see a positive direction. The marginal effect is 1.4%. This looks like a little, but again, remember, every delay is measured in months and months, and we have dozens of cases per judge. We also wanted to see the effect on the level of effort. So assuming that you do have those changes, every month of delay increases the effort. Our second hypothesis was, does this changes in work content affect the outcome of the case? Meaning they change the probability to end in settlement. So our results does show that with every month delay, we see an increase in the probability for judgment on merits rather than settlement or other things. So again, probably or assumably, those changes in work content had made those cases more complex thus reduce the probability for settlement. That's it. All I want to say is that what we find is mostly indicative. We see a strong indication of negative consequences of long lead times. So it increases the probability of changes in work content. It increases the demand for effort from the constrained resources, and it also affects the outcome of the case. And these consequences are not judges' behavior or anything. They're external, and they become more and more severe as lead time increases. Those again burden further the judges, thus creating the congestion vortex. Hopefully, this will create motivation to introduce OM improvement methods to this environment. Okay, thank you.
Thank you, Shany, very much for sticking to the time. So our next speaker is Fatima. Fatima, please, if you can share your slides. Yeah, we see it, but we cannot hear you very well. If you can speak a little bit louder.
No? It's okay
Better.
now?
Yeah, so go ahead, please.
Okay, great. Thank you so much. My name is Fatima Achamrah. I'm an assistant professor at the University of Sheffield. Today, I will present, let's say, overview of the results of research study I have conducted as part of my PhD in 2022, which is around solving inventory routing problem under dynamic and stochastic demons using genetic algorithm in deep reinforcement learning. So let's start with the context. So for decades, companies have been in antagonistic situation between minimizing logistic costs, namely transportation and inventory, guaranteeing the availability of products at the right place, at the right time, and again, at the most appropriate cost, and enhancing their performance, which must be that attractive to customers in terms of higher service level. Beyond that, nowadays, the logistics environment is becoming more than ever volatile, uncertain, complex, and ambiguous. And companies are therefore becoming more than ever vulnerable. To be on the top of their game, they must deal with globalization, fierce competition, new consumption pattern, emergence of new technologies, sustainability constraints, and so forth. Not to mention geopolitical wars, COVID-19, crisis that has led to shutdown of many companies and exposed the vulnerabilities of other, particularly when it comes to the unavailability of products. So in face of this, let's say, disruptions, companies need to be more aware that they need to be more resilient to deal with disruptive events without sacrificing cost effectiveness. One way to survive and then thrive in VUCA context, and perhaps overcome and profit of unexpected disruptions and events would be shifting from a decade or from decades old models toward new inter-organizational configuration based on collaboration. Collaboration, or companies in a nutshell can collaborate by sharing information, by making joint decisions, such as the VMI, the vendor managed inventory. They can also collaborate by sharing physical assets. For example, inventories of finished products or reusable packaging. They could share transportation means, machines, spaces, and so forth. As the product unavailability is frequently occurring, let's say, universal issue, and given the fact that it becomes a major concern in VOCA context. In this research study, we investigated two mechanisms to cope with shortages, namely inventory sharing and product substitutions. The objective is to highlight their advantages regarding cost reduction and enhancement of service level. In the literature, when inventory sharing is performed, let's say, between location belonging to the same echelon, it is referred to as lateral transshipment LT. LT can take place at predetermined times before all demands are realized, or at any time to respond to shortages of products. It has numerous advantages. For example, it allows for faster response to emergency orders, lower logistic costs. It may concern, let's say, perishable products, blood products, for instance, low demand items such as spare parts, fast-moving items such as packaged food. The unavailability of products can also be handled by promoting product substitution. This practice corresponds to the case where customers are given the choice to substitute preferred products with another with similar characteristics. Substitution may concern as well food product, blood products, spare parts, perishable products as well. So in the classical inventory routing problem, IRP, or vehicle routing problem, VRP, the main objectives could be to determine, for instance, which customer to serve, which products to deliver, how much to deliver, when to deliver. When the lateral transshipment, the LT, is considered, we should also determine from to which customers the LT will be performed, when to share, how much to share, which vehicle to use, either outsourced vehicles or the same vehicles that do the regular shipment. When the product substitution is also considered, we should take into account decisions related to the time the substitution will occur, which product to be substituted, how much to substitute, etc. By restricting the attention to optimization models in VRP, IRP with inventory sharing of finished products, we have reviewed over 200 papers published up to February 2022. The main gaps to be highlighted are the following. First, a few papers consider the stochastic variance of these problems, in addition to integrating or considering the fact that, considering, let's say, multiple product supplier settings. And apart from promoting transshipment between customers to avoid shortages, none of the existing papers incorporate substitution within a dynamic and stochastic settings. So in this research study, the objectives were to fill these gaps. More specifically, we considered a spare part supply chain with two levels. In the first level, there is a producer or manufacturer who supplies their customers via a central warehouse with original equipment manufacturer parts, OEM, and aftermarket parts. The aftermarket parts, let's say, refers to reverse engineered OEM parts that are cheaper, but designed to perform in the same way as the OEM parts. The main problems that can be encountered when dealing with spare parts are the dynamic and stochastic natures of the demons. The demons are intermittent, which exhibit an infrequent rate and extreme dispersal over time periods, which makes it challenging to reduce lost sales at the customer's location. So the objective here is to guarantee that the demands are met while incurring lower costs, which include transportation, inventory holding, and shortages. So more specifically, when dealing with dynamic and stochastic IRP, the objective is not to deliver a static result, I would say, but a solution policy using the information revealed, outlining which measures need to be performed as the time passes. So in a nutshell, to handle this aspect, the IRP problem we've tackled was solved in 2 steps. So before the demand is revealed, a replacement strategy is adopted in which anytime the inventory level of customer reaches a reorder point, a replenishment order to visit this customer is triggered. So their inventory level is brought up to a given value. Then a multi-product, multi-vehicle VRP noted here, RM model is solved to determine the quantities of product to be delivered to each customer and construct the routes accordingly. After the demands are revealed, and if the current inventory level of each customer is insufficient to meet the actual demand, LT and substitution are allowed to mitigate the shortages. These decisions are determined by solving a model called TSM. These steps are repeated based on the rolling horizon framework. So I think I will skip this part. This is just to present the models for the RM and TSM. Regarding the resolution approach, and given the fact that the model includes multiple vehicle, multiple product VRP, which is an anti-hard problem. And in view of this complexity, we use the meta-heuristic that combines mathematical model and a meta-heuristic implemented in a rolling horizon framework. The meta-heuristic called genetic algorithm is used to solve the RM model and determine routing decision. And given the fact that meta-heuristic in general and genetic algorithms in particular through their iterative search processes generate a lot of data that can be turned into explicit knowledge if coupled with machine learning model. So data related, for instance, to the objective space visited during the search process, movement, the illets and bad solutions could be let's say analyzed and used in order to extract useful knowledge to guide the meta-heuristic search performance and speed. In this study, we have used deep Q learning to speed up the genetic algorithm. Once the RM model is solved in the current period, the solution is used as a parameter for the TSM, which is solved exactly using Simplex software. So for the genetic algorithm, it works as follows. We generate initial solutions called population. Each solution is in the population is referred to as the chromosome, reflecting the sequence of assigned customer to each vehicle. During each generation, the solutions are enhanced using operations such as cloning, crossover, and mutation. Although
Fatima, one more minute, please, and we have to move.
Okay. So although the genetic algorithm has a strong global search ability, it has some limitation regarding the speed of conversions. So to tackle this problem, we have used reinforcement learning. So if I may explain briefly how it works. So the idea is to first to allow a given agent. So if I take an example of an agent that has a task to perform in an external environment, the idea is to first allow this agent to observe the environment, decide how to act using some strategy, take an action. At some later point, the agent gets feedback telling it how well they don't perform in that task. It either receives positive or negative rewards. It learns afterward from the experience and refine the strategy and iterates until an optimal strategy is found. So in our case, the agent represents the chromosome, the sequence of state action pairs represent the mutation and permutation moves performed in each iteration, and the rewards represent an increase or decrease in the objective function. This is like a presentation of the math heuristic. This is let's say machine learning package we have used to fine tune the parameters of the math heuristic. This is the instances we have used in order to assess the performance of the method, and also to assess the advantages of promoting inventory sharing and substitution on the overall performance of the supply chains, and that's it. Thank you. And sorry for running out of time.
Thank you very much, Fatima, for such a nice presentation. And now it's the time for Kseniia. We can see your slides, but you are muted.
Yes, thank you. Thank you, Vanessa. I'm just trying to make it full screen. Okay, no. Now it's going to work. Okay, perfect. So, hello, everybody. My name is Kseniia Kurishchenko, and I'm going to present you my work on explainable and fair machine learning by means of mathematical optimization. So it was my PhD topic, and actually this month I'm going to defend. So let's have a look what we've done in my work. As you know, most of the state-of-the-art machine learning models are seen as black boxes, and unfortunately in some areas, we need to use transparent machine learnings. For example, in allocation of social benefits, credit scoring, medical diagnosis. So mainly when we use personal data. Also, public authorities are demanding transparency in the algorithmic decision making. Some European law also being developed. So then when human lives depends on the predictions, we need to use transparent machine learning models. Mathematical optimization helps to trade off transparency and accuracy, and this is the goal of my PhD thesis. And under transparency, in this presentation, I'm going to talk about explainability and fairness. So let me start with explainability in machine learning. I want to introduce you several examples of explainable machine learning models. So first of all, it could be, for example, rule-based models such as decision trees. So while training, we obtain a decision tree, and when individual falls in a leaf, we also obtain the rule coming from the node so that we can, let's say, explain our prediction. Also, we have prototype-based models when we can our representative individual is going to explain the group of individuals. And also there are some sparse models, for example, lasso or best subset selection models. So the idea of these models that we want to use fewer features such that it increases our understanding of the model. Another concern which appears is some algorithmic bias. And here I give two examples of racial bias in health system and racial bias in assessment algorithms, algorithms for example, recidivism prediction. And it's actually crucial that automated decisions respect principles of fairness, such as that data can contain some sensitive attributes, for example, race, gender, or age. And in both of these examples, it was found out that there's racial bias. So, and in order to treat this, there are many approaches, and one of them is to use some unfairness measures. And there are many of them, and I'm going to present you one of it that we used in our paper. So let me dive into the paper that I'm going to present you today. It's on enhancing the explainability and fairness of tree ensembles. This paper is dedicated to the explainability and fairness of ensembles of classification and regression trees. And in this paper, we develop a model, a mathematical optimization model that weights the given trees in the ensemble such that it trade-offs the accuracy, sparsity, and fairness. So we are given a training sample with n individuals, and we have p features for each individual, and those individuals are split in k classes. Some of these individuals are in the sensitive group, for example, females, and we know that. And also we are given a tree ensemble of T trees, for example, a random forest or HD-boost trees or other type of ensembles. And for each tree, we know which feature has been used in each tree, and also we know the prediction that our tree gives for each individual. So the idea of our method is namely the explainable and fair tree ensemble, is to reweight those trees. So we allocate weights to those trees such that good trees can contribute more and bad trees can be even eliminated. And then the classification assignment is made by maximum score, where we have now our weight in front of the prediction. So the idea of our mathematical optimization model is that we want to minimize our misclassification error. We also want to minimize our unfairness such that we have high sparsity of the ensemble. And when I talk about unfairness, in our paper, we talk about an extra weight to the sensitive attribute. So, for example, our sensitive group is females, then we want our model to be more accurate on females than the others. Of course, we still want to have high accuracy on total and some sparsity. So let me formulate the model. Here is my parameters. You've seen already alpha, which is a weight of the fairness term in the objective function. We have parameter nu, which is the maximum number of features to be used in the ensemble. Also, we control the maximum weight of the trees, and it allows us to prevent overfitting. And also, we have parameter to avoid ties when we do final class assignment. Our decision variables are the following. We have our weight associated to each tree, which is a continuous variable between 0 and 1. We have only one binary decision variable which related to the features. And we have our auxiliary decision variable to model the score deviation, and it's a positive variable. So the formulation looks like that. So we have our objective function. In blue color are depicted our decision variables. So first term is our total misclassification error in terms of our auxiliary variable, and also the second term weighted by parameter lambda is our misclassification error in the sensitive group. And now I want to talk about our proxy variable Xi, which is score deviation. So the idea of using this proxy variable is that we want to avoid hard modeling of misclassification. because in this case, we would have a lot of integer variables related to misclassification for each individual. Instead, we have this continuous positive variable Xi, which models the difference between the maximum score and the correct score. And we want to minimize this difference, and this means that we want to minimize our misclassification. So we also have other constraints and the nature of decision variables. So in general, it's a mixed integer linear programming problem, scalable with the number of individuals, because the only one binary variable relates to the number of features. So usually it's smaller than number of individuals, and in general, it's also not a very large number. So let me show you some results we obtained on the COMPASS dataset. I talked about this a bit in the introduction with the recidivism dataset. And for this, in our numerical section, we use the following initial trees, which we are going to reweight, namely stump trees, so trees with the weight with the depth equal to 1. So for each continuous feature, we constructed most 100 trees based on the percentiles of the corresponding feature. So for example, we will have some trees like x lower with a node x lower than or equal than 1 threshold, then another tree with x lower or equal than another threshold, and so on. And for each categorical feature, we build one tree per category. Here you can see the description of the features, and let me show you the results. So here the out of sample misclassification year on the right, total year misclassification, and on the left our unfairness or fairness. So in actual terms. So we benchmark our model against random forest, and here on x-axis you can see how many features we are allowed to use in our model. So for random forest, we then pick up top, for example, 5 features here to use from the variable importance on the unconstrained random forest, and this is the obtained accuracy out of sample misclassification, sorry. So the main message from this graph is that our results, our model gives comparable results to random forest, even for the unconstrained random forest when we are allowed to use all the features. But at the same time, we are able to reduce dramatically the unfairness. So the misclassification error for the in the sensitive group in one of our experiments is going to be almost 0. Another good thing about our model is that we're able to use only few features and also only a few trees. So here on the right side, you can see the number of the average number of features we used in our ensemble, and on the left side, the average number of trees used with our ensemble. So as you can see, when we ask to use at most 15 features, our model still tends to use lower number of features, and it's very persistent. And also in terms of trees, we are able to use at most 70 trees. Another good thing about our model is that we could have this contribution to each feature to the score of class K1. So for example, let's consider this point here when we are allowed to use only 4 features. So then for each feature, we can count the contribution to the score. So for example, I'm a young person, so I have age around 20 here, and then other features, for example, are somewhere here for me. So then my final score will be this number plus that number, this and that. And if this is larger than 0.5, then I will be classified in class 1, meaning that I'm a recidivist. So This was my results for the COMPASS data set, but of course in the paper we have more data sets to discuss. So in this presentation, we proposed a mathematical optimization approach to make tree ensemble sparse and fair. We introduce a mathematical optimization formulation where there are no binary decision variables related to the individuals. We showed that we could gain sparsity without harming much the performance for the COMPASS dataset. And as I told you, for other datasets, you can see it in the paper. And for future lines of research, we think about modeling sparsity for categorical variables and developing fair treatment allocation via heterogeneous treatment effect predictions. So thank you very much for your attention. And this is QR code to our paper. Yes.
Thank you very much, Kseniia, for your nice presentation as well. So
Thank
now
you.
it's time for Professor Cartis to start with the discussion.
I would like to thank our 3 stars of today, Shany, Fatima, and Kseniia, for 3 wonderful presentations. I have learned a lot from you. I think you all gave great talks, really clear and very well prepared. And I really congratulate you for this and for your achievements in your PhD, for managing to produce this research and to continue until you know, to finish PhD and so successfully. So it is not a small thing. So it is a huge thing. So I really congratulate you all. I would like to start with Shany, and then so just go in the order that you spoke, if that's okay. Yeah. But I would like also that so even though I'm asking Shany, please, if Fatima and Kseniia would like to ask at the same time, please do. So I will definitely value that very much. In fact, if you would like to go ahead of me, that's also okay. Would you like to ask her something first, or should I go first? Should I go first? I go first. Okay, I go first. Okay. So I am not familiar, of course, with the specifics of judicial system and so on. So please mind my, I acknowledge my ignorance here. So please bear with me. My first question, what I didn't fully understand was whether the data that you have, so you have this this endogeneity of the data, but and sort of this is what you try to look at, these, like if you put shocks in the system, right, so that you see something above noise level, you try to see some kind of cause and effect, right, if I understood correctly. But what about heterogeneous data? So do you are these cases that you considered in your data set, is there any issue coming from having different kinds of cases? And so I saw that it was all civil, sorry, it was all civil cases. But are there within that kind of different types of cases, and how was that taken into account in your modeling?
Thank you for asking. So we only took civil cases because they are very different in nature from criminal cases where people are arrested and time frames are more constrained, right? In civil cases, it's more, you know, I don't want to say laid back, but it's less constrained as no one is in jail. So this is why we focused on civil cases. And indeed, there are different types of cases, and there's also different jurisdiction, right? There's district courts and magistrate courts, and there's, you know, even in body harm, you have a medical malpractice, and you also have car accidents. So when we took our well, it's not really a sample, but we restricted the population. We made sure that the combination of cases actually represents the rest of the data. And
Okay.
yeah, and also we used control variables to take into account those different factors in the different cases. However, I have to say that the process is the same, right? So the process is the same in all civil cases. You have discovery in the pretrial phase.
Right, like you were saying.
So the process is said to be the same, but the nuances are different.
Okay. The other question I had was, so does this, can you use this, this framework you set up for other types of extended delays and extended load delays in other kind of contexts? Maybe the NHS, maybe the health system in you know, some health systems.
Yes. Well, there's a lot of work on healthcare congestion, right? However, I think in healthcare, the service time, right? The actual time from when you, not from when you enter the queue, but from when you enter the system until you finish your process is much, much shorter. Here, because of the big in-process waiting times, the process takes a long time. So I can think about other environments like maybe, I don't know, insurance companies or maybe somewhere in project management. But what we're trying to say is that like in production, that you have inventory holding cost, like working process holding cost. In services, you also have work in process holding costs.
Right.
So it's mostly about extended load, but with long in process time.
Okay. Let me go to Kseniia.
Sorry to interrupt, but I think that Kseniia wants to say something.
Yeah. I'm going to let Kseniia.
Okay. Thank you. I just wanted also to ask you, sorry, maybe I missed it from your presentation. What was the motivation to use instrumental variable regression? Because, I mean, you need to have some unobservables, right? Or
So our main concern was reverse causality, right? Because if you have, what we're trying to say is that having longer cases creates more work and changes in work content, but also when you have changes in work content, it back affects the lead time, right? So we had to break this reverse causality with an external shock just to the lead time that would not affect the effort or the complexity or the changes in work content unless through that shock in lead time. So this is why we chose this.
And thank you. And what was your instruments? I think I also missed this.
Yeah, so we had two external shocks to lead time. One was a military conflict, lasted several weeks, that affected all the routines around not just the system, but countrywide. And we had a court workers strike. So court stenographers went on strike. So this canceled all the hearings. So all the cases had to re-enter the queue, which is what caused that shock.
Oh, thank you so much. Now I see.
Thank you.
Fatima, would you like to ask anything? You have any
Just
questions?
to follow up on Kseniia's last questions regarding the shocks, is it possible that you consider other shocks rather than strike in say conflict?
What, sorry, I'm not sure.
Is it possible that is it like your method is quite generic to include other shocks rather like in addition to the strike, the conflict you just mentioned?
So you're asking if I may accidentally included other shocks that I do not.
No, if you can, if you
Oh,
can.
if I can,
Yes,
yes. What I was when I was looking for the instrumental variables, this is what I was looking for, is if there's any external exogenous to the system shock that might you know, freeze the court system in a way that makes it prolong just the lead time without making any changes to the cases. So I found two. I was lucky to find two. So I just took both of them. Yeah, so I imagine, I don't know, they might be others, but this I found to be very straightforward in the sense of their exogeneity and of their shock.
Yeah. So if I understood correctly, your point was that you were trying to show that about these delays, even if there were not those shocks. However, because of the modeling problems, because of reverse causality, you had to kind of take it was to make your analysis clear cut. You had to, and correct, you had to actually include those shocks. But your underlying point is that you are trying to assess the delays that are there anyway.
Yes,
that is the problem. And
absolutely, it's
and
just for causality.
Yes,
it's just for causality.
Oh,
you know, observational research. You have to work with what you have.
Yeah, of course. Very interesting. Great. And what's your next step? So what are you making recommendations about what should change?
So my dissertation had 3 papers. The other 2 are already published. This is not. The other 2 deal with an implementation of OM methods in the Israeli court system, in the Jerusalem District Court, which I was involved in, and I demonstrate empirically its results. You can see in my website the 2 links.
Okay, very interesting.
And what I'm working on now here in Toronto in my postdoc, I'm working in collaboration with legal empirical researchers from Georgia Tech, and we are trying to create a very interesting data set of the US federal district courts, building it as an event log that will allow us to do process mining, to look at the process, how it really looks, using scraping all the case dockets from a specific court. We're talking about 200,000 cases were scraped using NLP models to figure out what happened throughout the case. And our intention is to publish this as a data set for the OM community to use to ask questions. And of course, we have questions that we want to observe, right? We want to use simulation models to evaluate impacts of different interventions. But first and foremost, we want to make this data set operation perspective to the community to use for empirical research.
Okay, thank you very much, Shany.
Thank you.
I would like to ask Fatima. So thank you very much for your nice talk. Very timely topic for what we have seen in the last few years for disruptions to supply chain. So I wanted to ask you a little bit about whether your demand, so when you were talking about demand being realized or not realized, so what was unclear to me was whether this was predicted demand or actual demand. Sorry, I'm sorry, maybe it's, I don't know all the terminology.
It's actually the actual demand.
The actual demand, right?
Yeah, when it's given the fact, like if I refer to the use case, it was around spare part. So spare part, given their nature, their demand are not that predictable. So we try to come up with a policy to see whether we can, when the demand would be realized and revealed, so we could know how much we need to meet. What would be the recourses in order to avoid any shortages that may occur at the customer's level?
So I didn't quite understand how you combined genetic algorithms with reinforcement learning. So if I could have a little bit more on that, because so what one sees with genetic algorithms is that they do not scale well, and also that they slow down. So if they have a good start usually, but then you'd notice a substantial slowing down and also the issue of scalability. So please, if you could tell me a bit more about that. It's a very interesting combination.
Yeah, we started from the idea that meta-heuristic included genetic algorithm use a lot of let's say kind of operators in order to enhance the solutions. And based on the kind of moves, the combinations that will be performed in order to enhance the actual solution, we could either counter two cases. Either we could enhance the actual solution or worsen the solution, if I refer to the objective function in this case. So the idea was to say how we could like make the process, the research processes more smarter and intelligent using reinforcement learning. So the idea is to select, given the problem to be addressed, and given the problem instances, etc., what would be the moves to perform, what would be the operator to use in order to enhance the solution, to speed up the algorithm, and also avoid any optimal the local optimum. That's it. So we try to use a lot of instances from the literature and started to store the data information related to the search spaces. What were the moves and recombinations being used in order to enhance like explore the research spaces, and we try to use the reinforcement learning in order to extract insightful information to guide the algorithm throughout the research space.
And how large were these problems? Sorry, I missed that. How large was the size of the problem?
Actually, we tackled lot of variants, but
okay.
we have used like the only benchmark instances that has been like used, but I think it's up to 200 customers.
Right.
And we generated other instances to integrate multiple products up to 40 and multiple vehicles up to 20.
Yeah. And I would like to ask Shany and Kseniia if they have any questions.
Yeah, I would like to ask a silly question. Could you motivate why you used reinforcement learning method? Is it possible to use any other time series techniques in this setting?
I think any method that would allow to capture the state action. I mean, kind of Markov process, I would say. So that could be anything that would model the action space and observation, this logic. So that could be other technique rather than reinforcement learning.
I see. Thank you.
Shany, do you have any questions?
No, great presentation. Thank you for sharing. Thank you.
What are the next steps in this for you, Fatima?
For the next, I think we, from my side, because it was in my PhD, but I'm working as an assistant professor. So the logic was to see how we could use reinforcement learning in general in order to solve combinatory optimization problems. And actually, I'm working on a research that tackles some VRP variants under uncertainty, and the objective is to see how reinforcement learning alone, not combined to meta-heuristics or exact method, could solve like this kind of problems.
So there has been some work in the global optimization literature and in some machine learning literature where they have tried to look at using, say, reinforcement learning for, say, making specific decisions when you solve mixed integers, so like branching rules and things like that. So maybe that literature could be helpful. So there is some work from Andrea Lodi, Pavan Kumar, I think Ruth Missner. So I think there is a little bit on this that may help you. It will be more methodological. It would be more on methods, but would give you maybe ideas for how to algorithmic ideas that then you could apply maybe in your more concrete, very practical context. Great, thank you very much. So I would like to move on to asking Kseniia. So a very, very interesting topic that I haven't done anything in that, but I think it's a great topic, and I'm very interested in this. So one thing I noticed is that your alpha equals 1. So the big question is, what should alpha be? So in your alpha equals 1 was performing best in many ways. So it was doing both on left and right plot. So the fairness was great for it, was the best somehow, right? And it was also doing well on the left side plots. So alpha equals 1 in your weighting. So that was my question about your objective. So you have a first term. That first term includes everything, right?
Yeah.
And then all the groups or individuals, and then you alpha equals 1. You just essentially kind of double. Well, not quite, because you have a different scaling for it. It's like 1 over n1, right?
Yeah.
So I just wanted to make sure that it's not that you're just adding these two, right? You already take account of the n1 terms in the first term of your objective, right? But then you add them again with the weight. Is that correct?
That's correct. So I would say, because I have this 1 divided by n in front of each term, so then of course with this additional term, fairness term, I increase the weight in the objective function only for those individuals who are in the sensitive group. So in the end, it will be 1 divided by n plus alpha divided by n1. So the size of the...
Okay, so why did you stop at 1?
Because we actually, of course, we conducted some experiments further, but we could see that after alpha equal to 1, this, let's say, converges to the same solution as with alpha equal to 1. So it's all data driven. So for the data we considered,
I understand.
We found this limit, let's say.
Right.
But of course, we couldn't guarantee that it will be the same for some other data sets.
Right. And so the question is, in terms of fairness, one can say, but what is the right weight, right? Why would, so you can see that, right, you get the best, in some sense, best results, but somebody could say, well, but is that really the best? So are you somehow biasing everything towards your, I don't know, protracted characteristic or something, your sensitive group? So how, what would be, I don't know, shouldn't the fair approach would be to somehow average over these things, over the different alpha values, or how could we make it, I don't know, methodologically, I don't even know how to say this, but somehow what would be fair to do to the fairness measure?
Yeah, I mean, it's, in the paper, we don't give any recommendations how to pick up this alpha. We actually try all of them, let's say. I mean, of course, with some limits, but we can see that the solution is almost the same in the end. So I would say it depends on how accurate in total we want to be, and how accurate on sensitive group we want to be. So it's again a trade-off. Of course, we in some cases, for some data sets, we could gain a bit of fairness without any loss in accuracy, but it's in general we have a trade-off. So we need to, an expert has to decide what trade-off to have.
How was the sparsity encoded? How was was it an L0 constraint or?
So it was yeah, that we want our sum over all binary features related to features being less than some number.
Okay, okay,
so-
right.
So then we couldn't exceed
Mhm.
to select more features. Yeah.
Have you considered group sparsity? So I was wondering whether group sparsity would be a reasonable model for I was thinking during your talk for dealing with sensitive.
I mean, group sparsity means that for some group we have one number of features allowed to select, for another.
Yeah. So you essentially you treat your group as a group in your sparse model, right?
Mhm.
With
I mean,
different weights. So I think there is some connection. Well, there could be some connection and some yes, some thought about this this idea of.
I mean, I don't know the exact, unfortunately, I don't know the exact definition of group sparsity, but if it's sparsity on different groups, then of course I think we could, then we need just to have, for each group, we will need to have its own.
Yeah, it's like term. It's like its own
Yeah.
term. Yeah, that's
Yeah.
right. Right.
So it's
Yeah.
possible to do.
Yeah, I think that could be maybe an interesting combination
Mhm.
there. So I think that was very interesting. Sorry, in the interest of time, I'm
Yeah.
already a long time, so I'm sorry. I'm very sorry. So yeah. So what are your next steps? What are your next steps?
So as I told, in 2 weeks, I will have my defense.
Yeah.
Yeah. So this is already a huge step, but with this paper, we are finishing the review report, and we will send it back to the journal. So I hope that it will be published soon. So yeah, so we have some good feelings about that.
Great,
Yeah.
great. Any questions from Fatima and Shany, Kseniia?
No, that was brilliant, by the way. And best luck for the defense.
Yes.
Thank you.
I have a short question. What you mentioned, you used also other data sets. If you can
Yeah, I mean,
say what are they?
yeah, so one of them is, so all of these data sets has to be used in fairness literature already. So because we need to, let's say, relate somehow that it's reasonable to do fairness analysis there. So we used, for example, diabetic data sets. So, and there we protect people with diabetes. So we also use some law school data set with the grades of students, and there were also I don't exactly remember whom we protect, probably females with low grades, something like that. So yeah, so and also we have used another data set, I don't remember exact, credit scoring data set, so German credit data set. Yeah, so and there we have a lot of categories, and it's why we, for future lines of research, we have this to deal with high cardinality categorical variables, because it's always a little bit different than with the numerical variables. So yeah, but we are trying to use as many as possible data sets, but of course we have some limits, let's say.
Yeah, great. So thank you all three of you. Wonderful. So we have a comment from Dolores. She unfortunately had to leave, and she said great talks, and she hopes to see you all soon. I would like to open the floor to questions, to some quick questions. I'm very sorry we dragged on, but please, if anybody has questions, please. So I don't
In
see.
case someone, I just want to say thanks in the meanwhile. for the Belén has a question.
Belén,
Thank you.
Belén, please.
Very interesting, the three talks, and also like also the questions that you and the debate that kind of like you created, Coralia. So thank you for being here. I have a question for Fatima about about the problem she tackles, and the when she faces to use like this combination of deep learning and or deep reinforcement learning and kind of like genetic algorithms. Did you feel like that you needed to use a lot of features of the problem that you had in order to kind of apply those techniques? Or it was more like something that became more automatic in comparison to other things that we do in OR, where you really have to use a lot of the properties of your problem? So did you feel you had to, or it gave you an advantage to use those tools using some properties of the problem you had at hand? For example, you kind of like copy things from other, or kind of like got inspired by other people using other similar techniques for other VRP models, or you just kind of like said, this is deep learning, deep reinforcement learning, and I'm gonna apply that directly. What was your feeling?
I think, given the fact that, like, first of all, we're obliged to as possible as we could to integrate and consider all the features of the problem. So we could consider all the characteristics of the problem at hand, and by doing so, we're able to compare our results with the only existing approach that dealt with inventory routing problem with dynamic and stochastic routing, inventory routing problem with transshipment, which was the adaptive large neighborhood search. And we wanted to first of all make life easier for us. So, but by trying to compare ourselves with the state of the art, so we could check the validity and performance of the algorithm, we had to consider all the features, and that was time consuming. It's one of the let's say time consuming task as part of this type of these reinforcement learning processes. And I think in order to, because again, it's not about generating solutions or outperforming existing solutions, but we wanted to give solutions in a reasonable amount of time, but that could also integrate real-world features. That's why we opted for that, I would say.
It makes sense. I think I love, like, when you think about other deep learning approaches or machine learning approaches, like more direct, kind of like you have data set, you know what your outcome is, your response variable, the other variables, and kind of like you have ways of, you can do it better or worse, more efficiently or less, but you can apply that. But yeah, my feeling is that kind of like there is also opportunities here for kind of like using the properties of the method. So
yeah,
and if you want to beat the system meta-heuristics, it looks like you have to do that, as you said. That makes sense, very interesting.
Yeah, it may worth noting that we have used reinforcement learning in addition to the genetic algorithm, also to exact method, which is branch and cat. So it's kind of math-heuristic that combine all that combines all these techniques in order to, let's say, generate good quality solutions.
Thank you. Very interesting.
Okay, so thank you very much. So I think that we can stop here. And well, before that, just let me show you, before we leave, just 1 second, I promise.
So while you're saying that, just maybe we'll take a screenshot before we close. A lot of people have had to leave because we had such interesting discussions today. And I loved the format. So
you're right.
very much. That was a really nice way of stimulating the discussion. So if anybody else wants to turn on their camera, so our young women can take a picture there and put it on their social media. So well done. They were lovely talks. I really enjoyed them. And lovely conversation and discussion.
Yeah. So who is taking the picture? It has been.
Nancy, can you do it?
Okay, great.
Done.
Good.
Great. Okay, so
Sorry,
just
Vanessa, I interrupted you.
no,
Off
no,
you go.
just 1 second. Perfect, Paula. Thank you very much. 1 second to say that we will have our workshop in the Euro conference on Sunday for those of you that are attending, and that will be some special sessions in which the Young Women for OR will present their work. We will have 2 more seminars with the remaining 6 Young Women for OR awardees and our winter event in December. And also I invite you to read the paper that Paula and Nuncia recently published about gender equality in OR. And of course, thank you, Professor Coralia Cartis, for being here today, and also for all the support from the Wisdom committees to organize this webinar. Here you can find all the channels of Wisdom. And thank you all for being here today and for this interesting webinar, talks, and discussions. Thank you very much.